Spoštovani, zdaj pa nadaljujemo z četrto predstavitvijo, oziroma predstavitvijo številka 3, in sicer tik pred odmorom. Naslednje predavanje nas bo popeljalo v svet Podnebju prijaznih betonskih prometnih površin, ki igrajo ključno vlogo pri zmanjševanju okoljskega vpliva infrastrukture. Ceste seveda igrajo zelo pomembno vlogo v infrastrukturi vsake države. Slovenci se radi o tem pogovarjamo, s pozitivno pa včasih tudi negativno konotacijo. Njihova izgradnja, vzdrževanje in vozila, ki jih vozijo po njih, porabijo pač velike količine energije. Posledica so emisije v ozračje, zmanjševanje neobnovljivih virov in drugi vplivi na okolje. Vsako zmanjšanje življenjsko potrebne energije, tudi le za majhen odstotek, pa bo seveda prispeval pomembne pozitivne učinke. Torej, betonske ceste so, to lahko rečemo, trajne, za minimalno potrebo po vzdrževanju, kar bistveno prispeva k trajnostnemu razvoju. Kaj zajema koncept podnebju prijaznih betonskih prometnih površin, pa nam bo zdaj že povedal gospod dr. Johannes Horvath iz podjetja Holcim Avstrija, strokovnjak z dolgoletnimi izkušnjami v gradbeni industriji in akademskem okolju. Welcome on stage and welcome between us. Hello. The stage is yours, Mr. Horvath.
Dobar dan, ladies and gentlemen. Thank you for the nice introduction. I didn't understand you, but I hope it was grateful for me. Colleagues, I have to bring down you now on the podium, so I will explain some investigations what we did in the last 10 years in Austria about roads, about urban areas. On the end, I will talk about sustainability. Sustainability, you know, mentioned all, wherever you are, concrete is not so good, it's a pollution for the environment, and so on and so on. Many facts, maybe some of you will think, yeah, it could be, but I want to show you concrete is the solution for sustainability and to reduce CO2. Of course, yeah, we pollute emissions, but we are also have the affordness to reduce the CO2 pollution. And that's what I want to show you now is on case of roads and especially of urban areas. I want to give you now some additional features, some additional properties about concrete. Concrete, yeah, you perceive it as cold, as hot, or not, sometimes in summer hot. It is hard, maybe sometimes dirty in the fresh conditions, but in general, we have to looking for new properties, for new value added. And that is the goal of that, what we do the last 10 years in Austria. What helps us in this direction, you know, we have 2013 a change of the construction production directive into the regulation where we have sustainability. Sustainability is important. Yeah. For all of us. I want to show it now on the other side because I'm sitting always there. There's always the lighting point on that side, so now I show it here. These 7 points is now important for us. Before we start this project, we have to think about the arguments. What is important for the future? What is important for especially urban areas when you think about sealing? Generally, we say, areas and roads are parts of our living spaces. Of course, not our living room, but every day, we need those roads or those places. This must be sustainable and valuable. And the next one are hard facts for us: energy saving, technology, low emissions. These are 2 factors I want to run through in the next 30 minutes. Safe and available must be also our roads and maybe some innovative luxury in motions. One part I want to come back is about energy. We had a project together, of course, with the university. Without university, it's not possible. We say light-colored concrete surfaces. So, you know, when you are busy in road construction or generally in sealing, the competitor of concrete is asphalt. Yeah? So we are white and the other is black. So maybe there is some difference, not only from the stiffness, The asphalt is flexible and we are rigid. They are black and we are white. Main topic or main impressions what you know are those called heat islands effects, yeah, nightmares of modern cities. You see here on the left side here some impacts, some phrases what we have to do. Important for us is increased heat island effects. Yeah? When you go out in front of the house, you see plenty of concrete. I would say it is good. It could also be black. What is the difference between black and gray? I would show you now. We perceive it generally when you go on a white or a bright surface, it's not so hot. When you go on a darker surface, it's more hot. So, and we perceive it, but we don't measure it. And the reason why we do it now, we find now evaluation method to see the difference between black and white colors. So effects, because it is more hot or less hot in a city or special in an area, small area. There were a lot of characteristics. It could be the buildings itself, the air pollution, yeah, the anthropogeneous heat, and the last one are the building materials. And that is the special influence what we investigated. Colleagues from the university found out, especially for Vienna, we made the investigation in Vienna, that the center of Vienna is an average 1.5 degrees higher than the suburb area. Yeah? That is similar to Ljubljana and to other cities. That is only the average. We found also out places where it is up to 3.5 degrees higher than outside in a normal urban area. What means this generally? When you compare it on the planet, when you go to the south, when you come closer to the equator, it becomes hotter and hotter. So you see here, plus 1 degree means about 170 kilometers to the south. So 107 kilometers to the south is nearly similar, the city to Vienna in between. Yeah, 3 point is about 560 kilometers and so on. This is only to better understand what I mean. So how we can assess the reflection and the heat island effect. We made investigations regarding luminescence. You see it on the pictures above. The luminance is the measurement of the reflection. The higher, the more reflections you have. And also not important is, especially in the night, the visibility of peoples, or when you go on the road traffic, you see better the other cars. To see it here compared to dark areas, you have here concrete made with white cement. This is the normal concrete. On the other side here, especially here is the white concrete, and these are the normal color of concrete. And here you have asphalt. This is mastics asphalt, and this is the normal asphalt. The factor from the reflection between black and white is about 3. You have here 5 and here 15. An additional investigation methods, we measured the albedo. It's also a measurement where you can check the reflection of the short wave radiation. And here you see also that what we did before with this method, it is right. The factor is about 3. The next step, we measured over a long period the temperature of asphalt concrete and normal concrete and the air. And you see here the heating of asphalt, the dark areas, and here is concrete. And this was the air temperature of about 25 degrees. So the difference between asphalt and concrete is about 7 degrees. What means that? We take now a diagram and say, there is also an investigations or an product out from the university. You can say, here are the temperature of concrete, here is the temperature of asphalt, and depends on the place where you are from the latitude. We investigated here from Vienna, and you have a shift to the south because it becomes hotter and hotter, but there's no big difference between Vienna and Ljubljana. And I looked on the map, Ljubljana has a latitude of about 46, so not a big difference to Vienna. The difference between dark and bright area surfaces are about 7 degrees. So the effect is, on the one hand, and it is now obviously, and this is approached and approved. First, the visibility is better with bright colors. Also, it is during the operating, there are also some savings, because you see here bright surfaces needs less illumination. You have more reflection, so the heat island effect could be decreased, and that's what we want, especially in future for sustainability. Concrete carbonites, so they take carbon and bounce it into the concrete. That is still now not allowed, but we are looking for that. Also, we get the permission that we can calculate through our EPD this carbonation factor additionally. Positive aspects for light colors in summarize: reduction surface temperature, cooling energy, reducing the heat in the city. And this is really an important fact. And now my competitors and my colleagues from the asphalt are shouting very hard now against to me, because in Austria, the local governments are really demands to such areas, because they feel or they perceive, and the population perceives, the cities becomes hotter and hotter. And with such easy way to reduce the heat increases, it's very, without much more costs, it's very easy to reduce such heat island effects. And additional, also the costs during operating, the light effect is also one big goal that we want to propose concrete. This is one fact what I want to tell you. The other one is the so-called sponge city. We're looking for purpose city. On the end, you know what I mean. We want to store the rain in the local area. We want to bring it in the sewer, so we have to use the rainfall locally. For that, we need purpose concrete, general purpose surfaces. You see here the advantages. On the one time, it is rain. When you have heavy rain, the sewer maybe are not able to bring the water away. You can store it in the surround. Then you have the possibility to use this water to grow up for some vegetations, for instance, trees, and also you can make maybe some aesthetical public areas. The way to proceed is quite easy. You need a top layer who is porous, who is pervious, who is permeable. You can do this with paving stones. This is one good opportunity. You can do this with paver grass or with grass pavers. You can do it also with porous concrete or with porous asphalt. And beneath, you need some layers where it is possible to let the roots grow and where it is possible to store the rainwater. On the end, you see it here. That is the idea what we survive and what we pursued in Austria. These are some shining examples for Austrian villages and for also some clients who are convinced about this technology till now. We go on further and further. Also now the city of Graz is very interested to refurbish new areas and new roads with this new technology, Sponge City, and Austria Schwammstadt genannt. You have here the possibility for roads. You have here the vegetation and here the walkways. Here you can use normal paving stones. Maybe you can do it here with paver layered concrete or manually placed concrete. So it's a good opportunity also with bright surfaces, of course. And this is the idea to reduce so-called heat island effects in our cities. Another example what we did in the past, a few years ago in Vienna, is Seestadt. You see here the solution was not with concrete, it was the solution with paving stones. Paving stones have generally the advantage if you have some works to do afterwards. You have to make some earthworks. You can put it easily away, you can place it easily, and you finish this in a really small time. Now, Ljubljana is a shining example for such technology. I get these photos from André. He was my colleague 10 years ago we start with this topic. Also here in Slovenia, I don't know generally if they have the same mindset behind them, but you know this place, Slovenska cesta. In the middle, you have a concrete road. Here you have the paving stones and the vegetation. That is the right way to reduce heat islands effects, to store rainwater locally. This is the idea what we have in future, and that is what we pursued in future. Of course, also our company did additional investigations. We are inventing a special materials called hydromedia. It's nothing else than a purpose concrete. You can use it for different applications, also for the rooftop or for places, for urban places or for heavy traffic. It depends on that what you want to do and how to act. You have different requirements for that. On the end, it's nothing else like a purpose concrete. The problem is that you lost the small size aggregates, and therefore you have maybe problems with the tension strength of concrete. To increase the tension strength of the concrete, it's possible to, or it's necessary to put some polymers inside, and this is maybe not so sustainable for the future. We will see, but maybe for urban areas it's a good idea to reduce the so-called island effects. What we can offer you, if you're interested in that, we have an own tool to make a special mix design. There's another application where it is maybe a good opportunity to use this purpose concrete. This is for rail tracks in between to make it drivable, especially for the blue light. Additional advantages when you have a porous concrete, also the sound isolation is better than you have a hard surface and you have a smooth surface. The problem, if you use it for the road, it needs maintenance because during the dust over the year, the pore props, and so you need a cleaning with high water pressure jet. This is the one disadvantage, I would say. One impressions of Vienna, I also made some tests in our plant close to Mannersdorf, how to place it. You can do it, as I mentioned it before, either by paver or now here it manually. It is, the consistency is not so high, so more in a dry consistency you can place it. And that what you see here in a cross section, that is the result of such a top layer purpose concrete. Thank you very much.
Dear guests, spoštovani gostje, mislim, da po vseh pomenljivih predstavitvah in po pomenljivih uvodnih besedah, pravzaprav smo že na polovici našega posveta, smo si vendarle prislužili en oddih, eno osvežitev, zato vas vabim na recimo da 20-minutni odmor, potem pa vas vabim na drugi sklepni del našega posveta. Hvala lepa za pozornost in čas za zdaj, pa se srečamo čez 20 minut. Hvala lepa.